So, thank you so much for joining me here. And it is a plenary discussion, which means a discussion with everyone present. That means you are, of course, invited to also be part of the discussion. We're going to have a chat here. If questions come up, then just raise your hands, and then I'm sure that someone will come running with a microphone. But I would like to just throw in the general question, is AI changing the game? Who would like to start?
Well, so as you heard the presentations multiple times, the roots of AI go back more than 60 years ago. And root of just deep learning, you heard that had multiple revolutions. One in the 50s, very rudimentary networks came up. And in the 1956, 57, if you saw the cover magazine, the cover of the Life magazine, you will see a note saying artificial intelligence has arrived. Okay? It was based upon the success of the very simplest neural network, perceptron, being sort of trained. And then pretty quickly people figured out that it had really not much of a utility, a much simpler statistical model could do far better. And then there was the first wave of neural networks and it went away. In between came the other waves. It was a very nice presentation this morning that I enjoyed. The second wave came in the 80s and of course it sort of subsided. And the third wave, of course, is something that is more like a storm, and that is not to be ignored. And I'll give just one example, and I'm sure many have been given before. There's one other example that was given on one of the talks earlier was that in the 1995, IBM Deep Blue beat the world's chess champion in chess programming. And that is very interesting because Herbert Simon, one of the founding fathers of computer science and one of the founding fathers of AI, had predicted in the late 50s that pretty soon, within 10, 15, 20 years, computers would beat the world champion. And that time came and went away. And I was a student, of course, in the late 70s, and we used to talk about it, the fact that you need much more than just brute force computing to be able to beat a world champion. So it took almost 3 decades for the computer program to beat the world champion. And just a couple of years ago, because of the advances that sort of are at the corner of computing, data, and algorithm, machine learning, we have reached a point where a program, just given simply the rule of the game and enough computing power, can learn to play against itself, and within hours, literally within hours, could train could beat the expert. So things have changed quite a bit in the sense that there are many applications, but this is one example that has to make you think, and something has changed. You can't just simply disregard the algorithm advances.
Well, I may continue more from geoscience perspective. I think it is clear, probably for everybody in the room, that AI is now becoming increasingly important when it comes to process the huge amount of data and so on. I actually want to recall example Isa colleagues mentioned in another panel discussion. He says AI in geoscience for him is reminded him the time switching from the bike to electronic bikes. And you know that last year, according to PwC and the ESA joint study, €1 in the Copernicus program, simply because the big data becoming available, sustainable data, already ended up with about €4 in the downstream application. I would be wondering if we now be able to really unlock the power of AI for this kind of data analytics, which kind of number we will then have in some years.
That does work. I don't think anyone's going to disagree that there's a big impact. I'm sometimes worried about the terminology, AI and machine learning. They're used interchangeably and they're not really the same thing. I think the machine learning that we use currently tied to the large data sets that we deal with in geospatial and geoscience, they're so totally coupled now. It's hard to see the two being separated. We're not going to be able to deal with the volumes of data that these new constellations of Earth observation satellites or in situ measurements create without using machine learning to interpret them, literally because there's just not enough human eyeballs and human brains to look at all of the information that's going to be created. But I like looking at it from a slightly different perspective. I think the impact of machine learning and perhaps more broadly AI is demonstrated by the user interface that we all use. Most of us, I'm sure, grew up watching, science fiction films on TV or reading science fiction books, and the interface we all assumed that we would use when dealing with computers was actually the interface that we are starting to use, voice-based, ubiquitous computing, where the actual computer itself disappears and we interact with, computing that exists in the environment around us. And all of that is completely reliant on AI. And I think that's going to be the biggest change in what we do, that move towards more ubiquitous computing that in effect disappears into the environment around us.
My question would be, what is your experience? How open are people to the new technologies? Because that seems to be a big problem.
I think we're probably more open than sometimes the media and the press would like to have you believe. So how many of us here use Siri or the Google Assistant on our mobile devices?
Alexa.
This is Berlin. It's not perhaps the best, most reliable audience for these things. Okay, well maybe not. But I know my kids use the Google Home speakers that we have at home all the time. It's a natural user interface, and if maybe you're not using it, if you have kids, they probably almost certainly are using it.
So do you feel that the new generations coming up, that they wouldn't have any issues? Because the question that gets raised all the time is, what happens as soon as, you also talked about sharing data. I feel like that is the biggest fear of people. I always hear, well, what happens if I give people my data? I don't have any control.
Yeah, it's actually privacy is still the issue there, right? I must admit I'm not using the Google Assistant, but the Amazon Alexa, and I have it at home, right? And it's still, it's super convenient if you come home and say, okay, turn the light on, and the light turns on. If you leave home and you say turn the vacuum cleaner on, and then the vacuum cleaner starts cleaning, and you come back, everything's clean, right? It's super convenient. But of course, there's a certain type of privacy issue there, right? You don't know what exactly is being done with the data that's being sent back home. So that is one aspect, yeah. But I also wanted to say something to the previous speakers. So I see, to me actually, the term AI. Well, I don't really care if it's a machine learning AI or just a simple heuristics. At this moment, we really are stuck in the way where we really have too much data. Yeah? Back in the days, TomTom acquired this mapping company, Teleatlas, yeah, long time ago, and mapping back in the days was done manual, right? There was someone really looking at the images, drawing lines, doing all this. And
me, I did that job.
Poor you. Yeah. Okay. No, but it's a boring job, and you. Okay, it's the first time that TomTom and Google agree. Okay. No, but we have the expectations also to mapping service provider. The map is always up to date. They increase like hell, and the only way to do this is via automation. And if automation comes from whatever heuristics, machine learning, AI, this is I don't really care a lot. Yeah? But of course there have been breakthroughs just because of the machine learning algorithms, like the image, like the deep networks. But just using machine learning already made a big difference, like basic machine learning. Yeah. Okay. Now I'll kill the discussion.
Can I say something?
Yes, please.
Because I think your question was very open. So I would say my impression is that we don't yet see a disruptive impact. And even if we look at today, we hear the examples we have today, they're all great innovations, but they're not game changer per se, individually. They help improve services and can make new research available, but they're not a game changer. They're not the singularity we were talking about many years ago. These are mostly about image recognition and natural language processing. And so I think there is a feeling that we still don't get where is this big change. For me, the most interesting part is not in the individual eureka innovation per se, but in the wide availability of this innovation. We have talked about open source software, we talk about open data set, accessible. I mean, basically, machine learning is widely available to a very large number of scientists, and this was not the case in the past. I think this is, not only scientists actually, the user interface that we're talking about, Siri or Android, is in the hands of everyone. This is, for me, much bigger change than the individual innovation that we say, oh, we have, the computer becoming more smarter than the person.
And what do you think the next steps need to be for it to be game-changing?
Oh, it will be a game changer, I think,
Okay.
but it's a self-reinforcing mechanism. We're talking about data today, but the slide I showed is we need data to train algorithms and to have machine learning, and then we'll have great things. But the reality is that it's a self-reinforcing mechanism because machine learning can be used to have better data, to have new data, so it will become a self-learning mechanism, and it will grow, and it will have a critical mass where we'll see a disruptive change, but I don't see it yet in the individual application. That's what I'm saying. When you look at the images, and I also say it for the sake of discussion, to provoke a little bit of a discussion.
Very good.
When we look at today, okay, we say computer recognizing images better. Mm-hmm. That's great, but per se, it's not the invention of electricity. The fact is, cumulatively, it will lead to disruption, for instance, in the Sustainable Development Goals.
I'd like to pick it up on that. So I think it's wrong to say that the technology hasn't led to disruption yet. If you're in the middle of a phenomena, we are late to recognize it. And of course, we are far from singularity. Singularity is a concept that's just too far out. I mean, I don't believe there'll be a singularity. But I think we're in the middle of a disruption. It's happening very slowly around us. You can see it in many sectors of the economy. If you look at the retail sector, especially in the United States, very slowly all of the big box stores, the big buildings, people selling stuff, they're slowly going away. Department stores are closing one after the other. They're being acquired by other bigger companies, and then of course eventually you would sort of see them completely fall off the cliff, all because of online e-commerce that's happening. And that would not have been possible before. I think when you asked about how many people are interacting with Alexa and Google Play, very few went and signed up. And actually, I don't use one of those devices either. But I have a 3-year-old grandchild, and who just lives by these devices. I mean, he just barely learned to speak, and sort of would train it to sort of sing whatever songs he likes to play. And when my daughter moved from one apartment to the other, Alexa was disconnected, and this little kid started crying. He just thought something happened to it because it's not responding to my command. I mean, it's like emotional reaction. So I cannot imagine. I could not have imagined something like this 30 years ago, 20 years ago. These things are happening. They're happening slowly because we are living in the middle of those revolutions. There are many more such things happening right now. In the United States, we have very small unemployment rate right now. And pretty soon, there could be big disruptions. A lot of the people who are driving trucks could be completely out of job in 20 years or 10 years or sooner because of these self-driving cars. It's difficult for us to imagine that all of our cars would be automated in the next 5-10 years, but portions of it could be automated far more easily. Trucking is, for example, one of those industries. So there are, you don't find many receptionists now. 40 years ago, when I started my academic career, each professor had an administrative assistant. Now you have just a couple for the entire department because everybody does their own things. So things are happening. They're happening at a rate faster than you can even feel, and they're changing us. They're changing us all. There's a lot of upheaval on a political and social level around the world, and at least some of it is fed by these technological changes that we are seeing around us.
But sometimes it's that fear that you address that, for example, some people will be losing their jobs, and the technology sector will be the ones, they will be the ones that are winning. So what can one do against that? How can one make sure that it's not only the technology companies, or not everyone can become a programmer or computer scientist? So how can we help with that inequality?
I think the impact is going to be much broader than that, and I think even within the IT sector, there are jobs in the IT sector that will disappear to be replaced by algorithms, by machine learning. You know, there are many sort of zero-code solutions appearing now where, you know, programs can almost write themselves by plugging together different processes. So I don't think any sector of society is immune from that. I think, you know, if you really want to maximize your opportunities to be employed in the future, you know, focus on the things that are human, that are about empathy, that are about creativity. If you want to be an actor that's powered by machine learning, that's kind of unlikely. I think you're much better off focusing on that. But you know, this is nothing new. Once upon a time, perhaps when this building was built, it didn't have an elevator. But when the elevator was installed, there was a man that operated the elevator for a number of years until people were happy with the fact that actually that could be automated, and all you really needed to do was press a button, and the process of changing floors and closing and opening the doors could be completely automated. It didn't need an operator anymore. So, you know, progress happens. And the types of jobs that people do as society will change. You know, once upon a time, most of us would have been employed in agriculture. A little bit later on, it would have been in heavy industry, making things. Now we're beyond that. We're now in the service knowledge economy. These things change over time.
But it almost sounds like a vision where the computers would be getting rid of the human race, basically. If they start teaching themselves and being smarter than the humans, then you might have a couple of actors and actresses, but...
Yeah, it's the common concern that, you know, at some point Skynet will be switched on and eventually will replace all humans. I don't buy that. You know, I think we can make greater use of technology to replace the jobs that actually, you know, in many cases are actually probably better automated. And we can spend our time doing, in many ways, jobs that are more creative and that are more interesting. So, you know, as I said at the beginning, I'm an optimist. I will always look at the optimistic approach to technology.
I want to give a very short comment to that. So, there was a discussion I had with doctors. They were afraid in the future there will be AI or doctors. But in the end, a lot of the machine learning techniques and the AI methods, they will become standard tool. I think it's a competition between AI-powered doctors or doctors without knowledge about AI.
Thank you. We have a question from the audience.
Yes, thank you very much. Matthias Hartung, my name, from Target Energy Solutions. First of all, very much thank you for all the panelists here for very exciting presentations and contributions. Now, I may be a bit impatient, but I feel there is no disruption yet. I think you have shown us very nicely where there's an abundance of data, like from social media or from remote sensing, that ML and AI works, and we can make more to it. But we are full here an audience of geoscientists that also look at the subsurface, that are looking at raw materials. Our host, the Federal Institute for Geosciences and Resources in Raw Materials, is also looking at the subsurface. What are the blockers to make machine learning, to make all the technology work? If the AI and ML is the engine, how can we get the fuel, the data, to work in the subsurface?
So this problem is not just for the subsurface geosciences, but it sort of comes across in many, many disciplines. Okay? And you're absolutely right, some of these most spectacular successes of machine learning have been in places with even lots of data. Okay? And to the extent that many people in my community, computer science, machine learning, take pride in the fact that they can build these knowledge-free models. That is, you give them data and then they work. Okay? And they got it right to say that, at least in limited domains, for example, in language translation. 40 years ago, when I was a graduate student, DARPA in the United States had simply shut down a program after spending millions of dollars and tens of years of trying to convert Russian into English, the Cold War time. We're not going anywhere. So progress was very, very limited. And today, you can take your phone and go out anywhere in the world, and then you point it at any language, and you can get the translation, pretty decent translation automatically, without using any of the advances that were made in the field of linguistics for the last 40 years, and they have been tremendous advances. And it all happens because there's an abundance of data. Trillions and trillions of sentences exist in every language, and you can just learn statistical relationship from them. But this approach doesn't go very far, as you have said. Number one, it doesn't apply to anything else that's outside this data-rich domain. That's one part. Even in the domain of linguistics, it doesn't go very far, because this program, this little machine that I point at a text, does not really understand anything. It gives me a translation, but does not understand anything. Whereas the people who are working in the field of linguistics are building knowledge layer by layer and improving upon it, even though they cannot produce a program that translates as well as a Google Translate can do today. But the next generation of linguist students would build deeper knowledge of these phenomena. Now the question is, so a question that is being sort of thought about with great interest and around these different disciplines is, can we make use of this technology of machine learning and AI that have been so successful in certain domains? Does it apply to domains that are data poor? And that's how I'm viewing your question. And my answer to it is, if we continue to work on the same kind of techniques that we've been working on so far, the answer would be no, for a number of reasons. One is, of course, your domains are not data rich, many of them, number one. Number two, even if your domains were data rich, I could be producing models that would produce results that are not scientifically meaningful. Okay? For example, you would expect a system to follow certain natural laws, physical laws or chemical laws or biological laws, and this machine that would have learned from these statistical relationships is not guaranteed to follow any of them. So that's the second part. And the third thing, which is really the biggest Achilles heel for this machine learning algorithm, is they can find relationships in as much data as you give it, but only in that data. That is, once you have a data which is from a completely different distribution, sometimes it's called out-of-sample generalization, they completely break down. So there is no way that these techniques could help in a situation like this. Having said that, I think there's a tremendous opportunity to leverage what people have been working in the scientific disciplines for decades and decades and centuries, and combine it with the advances we have in machine learning. And a number of people are beginning to pursue this under the guise of physics-guided machine learning, theory-guided data science. This topic is becoming so popular now, and the idea there is that you have your machines learn from the knowledge that you have as opposed to ignore it. So there have been cases, and I can certainly give you examples at length, maybe on one-on-one, in which these machines, when they learn from the data generated by the physical models that are very inaccurate by themselves to begin with, can learn enough that by given small amount of observations, they can outcompete the very best physical algorithm. So here what you're seeing is a marriage of machine learning with the traditional scientific discipline. If you put them together, you can go much farther. If you ignore one of them, I guess we can just keep talking at each other.
If I may comment, so well, I tend to disagree that like if you have domains with little data, that does not. I mean, there are already breakthroughs there. I mean, they're not maybe not as big as you want them to be. But I mean, I remember like working at some point in computational chemistry, where you do basically drug design. You try to design drugs, right? And the company here in Berlin and. It was already then, back in these days, like whatever, 10 years ago or something, or even longer, you were predicting basically if, like, by how much a molecule can be solved in water. And you did only have like very few samples, and it did cost you like whatever, $1 million or more to like analyze the properties of this molecule that you came up with. But you could do things like active learning, where you like sample by sample, analyze, do measurements, and like speed up the process in which you find drugs. Then, or for example, I have a friend who is like a professor working in personalized medicine. Yeah, so we are like targeting, like trying to have individual drugs, right? I mean, medicine is at this moment like it's kind of like a hammer, like one size fits all. But it's like it's not the thing to do, right? And there's very little data there. It's like super privacy critical. There's nothing to be shared. It's like lots of issues, and nevertheless, we make progress there. Yeah, so maybe just on our path, yeah, in improving things. But the way I see AI is really a tool for automation. It's really a tool that is actually across all disciplines now basically ambiguous, right? It's not ambiguous, everywhere. Oh, it's basically everywhere there, right? We use it in physics, we use it in chemistry, we use it in biology, we use it in even geospatial sciences. It's a tool like statistics that is or math, basic math, to improve things.
Adding on this, on the example of health, there is also technology and data are one important factor. Another factor is market and demand and business case. And there are areas, data poor area, where with strong business case, where basically data generation, like in the case of pharma, in the case of randomized controlled trial, generation is very costly, but it's still produced. So it depends not only of the opportunities in terms of data availability, but also of the business case of the proposed solution and of the potential market. If there is a potential market, then data generation can be produced, and there are actually companies who, for instance, when it comes to road signs, that prefer to gather their own data through photos rather than relying on third-party data, even if it's such an additional cost, because the benefits are so significant.
Yeah?
Yes, Eirik Larsen from Earth Science Analytics. So thanks again for great talks. We're talking about big data and machine learning in the geosciences, and we've seen from your talks some great examples of what can be done with machine learning today in terms of taking some data like satellite imagery and matching it with some labeled data and create maps, for example, building heights, environments, etc. And we'll see more examples also on interpreting seismic data, borehole data, logs. So I think we're looking at what we're seeing at conferences like this is the first tier of AI, right? So it's A to B mapping with data, features, and labels. So let's imagine that we succeed as a community to share this data so that these maps and interpretations that the AI creates is shared to a large enough degree, and you use that to feed the second tier of AI. How do you imagine that would influence the geoscientist's life? So what we're seeing now is that some tasks are being automated, but if we could feed the AI with the output from the things that you're doing, then what would it look like?
I think that's a very, very good question, and I think it's a very relevant one that we should be thinking about. I think, as you rightly say, our experiments, our experience in AI and machine learning at this point are just scratching the surface. You know, we're the toddler that's learning how to walk in this space. And I think we are largely dealing with that process of automating our understanding of the data that we're capturing, segmenting it, perhaps getting to the point where we can automatically monitor change in the environment, holding the mirror up to the earth. I think we're getting to that point quite quickly, that we'll be able to recognize a change in the environment automatically at any point somewhere on the planet quite quickly. I think the next step will be then to take that real-time data that we've got for the world at a very granular global scale and use that for more advanced modeling to better understand the processes that are at foot, particularly around climate and the hydrological cycle. I think there's a lot of work that we can apply machine learning to perhaps existing models and flex those in different ways. And I think that's the next stage, going towards actually understanding the processes as opposed to automating snapshots of the planet.
You had a question, is that right?
Yeah, it's just with respect to the small number of examples available and your point. Thank you. Your point was that in some cases you don't need thousands of examples to make a good model, a machine learning model. So in the examples you gave for the medicine, the molecules that are soluble or whatever, what's the minimum number of examples where you're able to label that you think is potential? And then on the other side is there a data richness, asterisk beside that? Is like for an image, it's very shallow, the information, you're just looking at pixels, but in certain cases you have 100 labels, but you could have 20 or 100 layers of data for each one of those.
I mean, it's always a trade-off, right? I mean, if you are actually able to measure the property, yeah. So say you are able to measure the weight of a person, and you want to predict the weight of a person, yeah. Then basically, when actually not the wrong explanation. So if the weight of an object is the discriminating feature, yeah, then and you are able to measure the weight exactly, yeah. For example, you want to distinguish, I don't know, a plastic apple from like a real apple, yeah. Then it's actually this one feature is sufficient, and you will probably need maybe 30 examples to estimate the mean, and you're done. You don't need like super fancy machine learnings. This will be sufficient. If you say do something more crazy, I don't know. For example, you observe all these GPS probes driving around, right? You can detect traffic jams and stuff like this. But say you want to predict the weather based on this, yeah, which is I think feasible in some sense because people when it's raining, people used to use more cars. Yeah, but it's a super indirect measure of the actual thing. Then you will need a lot more examples to get all these statistics going, and you need more complex models. And it's the same in these images. If like the object is like very clearly distinguishable, then it will be easier. You don't need a lot of data, and you don't need super complex models. But the more indirect it becomes, the more difficult the machine learning model will be, and the more data you will need.
45 years ago, somebody wrote a paper. These topics we're talking about were debated back in the early 70s when people were doing pattern recognition. They were looking at images, but very simpler images, and doing classifications. And the summary of a very short paper was that if I have the right feature, I can work with very few samples. So if you give me the data, and if you have just the right feature, the feature could be the classification label itself. And someone talked about quantum computing today, right, in the opening talk. Maybe the quantum computer would give you the right feature, and then you won't need anything else.
There's a question there.
This is a conference on geosciences, so that's why I think the arguments about whether we have a game changer here with respect to unicorns or startups, I think is not so relevant. So the question is, do we have a game changer in the geosciences? And the question is, where's the game changer? Let's find the game changer. Is it machine learning? I don't think so, because we have done machine learning since we have remote sensing in Earth observation. Simply maximum likelihood estimators, support vector machines, etc. And deep learning is yet another method, which is better, of course, because if I have, instead of 50 parameters, if I have 50 million, why should the model not be better? This is clear. But I think this is not the game changer. The game changer is the free and open data policy, first, of Landsat, of ESA, of the European Commission, which allows everybody to access this data. A second game changer was definitely Google Earth Engine. Both of them are, or other platforms are democratizing the use of remote sensing data. We have in Germany, we have this every year, we have this contest of young people doing science, Jugend forscht. And we had one of the winners here. He used Sentinel-2 data for biodiversity of forests and won a prize. So this is nothing special, but he was 16 years old and he used neural networks. So I think the democratizing of this data is very important, and in particular for geosciences and for global change research, we can do now today what we have never been able to do. So I'm 30 years in the business, and the way how Earth observation and geoscience is done today, I've never experienced before. So if you have an algorithm, we can immediately roll out it for the whole world and do a global change research. So I think there's a few components are coming together such that we really have a change, the game is changed really. So insofar, you're nodding exactly, I want to confirm your point, yeah.
No, I think you're right, and actually it's probably the other way around. The availability and accessibility of Earth observation data, open data, has been a game changer for machine learning. You know, we wouldn't be here talking about machine learning if these data sets were not available.
But it was said before that it's very difficult to monetize data. What are basically the incentives for people that they want to share the data that they have, instead of thinking, okay, maybe I can benefit from it, or our company or organization can benefit?
I think within the realms of this audience and for scientific environmental data, we're capturing it for the benefit of society. You know, we're doing science, we're hopefully improving the way that we manage the environment around us. That's the motivation. That's the motivation behind the European Commission making Sentinel available and USGS making Landsat accessible. For the use of perhaps the types of data that are more controlled by GDPR and are more privacy sensitive, then that's a whole different debate. And I very much agree with the points that David made about GDPR and the shadow that it's casting over the industry at this point in time. We're still working out what does it mean for data sharing, because on one hand, you've got the European Commission saying, yes, we need to share data much more to allow us to live in this machine learning future. And then on the other hand, you put in place GDPR that says, no, you know, you need consent for everyone to use data in any particular use case. And to me, they seem maybe contradictory at this point.
And what do you think is more the problem? Do you think it's the politics, that there need to be regulations where they say, okay, you need to share a certain amount of data, or do you think it's the scientists who need to be more open with the data?
I think the scientific community is reasonably well served in terms of the governance and the frameworks. We've said, you know, there's usually the expectation that you're creating products and services for reuse within that open scientific community, and that tends to be the case. I think around some of the more commercially sensitive, privacy-related data, there does need to be greater policy frameworks and legislation about how that is done. But the motivation should be that you actually want to do this, that there is a value perceived in sharing data. My personal opinion, and this is a personal opinion, is that where we sit at the moment, the pendulum has swung a bit perhaps too far, and the motivation is to not share data, and that shouldn't be where we are.
But you also said you're an optimist, so you're very much for what is good for society and what is good for the world. But I think it's undeniable that there are a lot of companies that what they are focusing on is their own profit, basically.
Well, focusing on profit and focusing on things that are good for the world aren't necessarily in conflict.
Okay. Yes, please.
I want to approach this question from a slightly different perspective. I feel actually in our community we are missing very clear ethical guidance when we share the data. I just can take my personal research as an example. I showed today the enormous data we are making available, made public. But from my perspective as a scientist, I don't have a clear guidance. How could I avoid this data could be abused for other purposes? With the goodwill, we're providing the data, very detailed data about slums with the hope the authority will improve that area. But just imagine they could also have used this data to kick out people from the slums. So, I mean, this is something I think really need more awareness in the community. All in all, with all this data, we are delivering the things which was not there before.
And what would you think would be the solution for that?
Well, as I said, we'll probably need really more ethical guidance in handling this.
But in form then of regulations or in form of communication and trust?
Both.
Okay.
Yeah.
I would like give another perspective again. Yeah, so there's, there's one incentive to make data publicly available, like from like these research bigger like research funds or like governments. Yeah, so you want to foster innovation, you want to like strengthen these, you want to like have basically many teams working on these. Yeah, so that's all good, nice and good, but the researcher. Himself. Well, they have the issue. They want to publish, right? And the currency for them is basically the number of publications / number of citations. If a researcher gets a lot of citations for publishing the data associated to what they are doing, then they will. Then this will be like a cycle, it will be a cycle, right? I already told like when I was asking you the question, right? So I'm really wondering what is different with algorithms, yeah, with software. So 15 years back, yeah. So there was no machine learning open source software, right? There were all the tools were closed. They were in-house. Like people were like very protective. No one was sharing. No one, yeah. You get arguments like, yeah, but like each team, each university, each community, they all built their own toolbox with machine learning toolkits. And now it's kind of like the complete opposite, right? Companies are like, they're actually competing with toolkits, trying to be like the number one toolkit to attract people. Yeah? It took a long time to get this change going. And I don't know. I mean, I don't know if we had some impact back then. But what we did there is we really made it possible to publish data. Yeah, so you got citation, not data, software. So you got citations, you got some credit because this was actually not considered scientific work back then. Yeah, and polishing data and making data available and maintaining it like that it's still available on whatever service is work which is not a currency in research. And it was, I think it's a similar problem Plus, and that's the other the thing I see is the privacy factor. And I think actually GDPR is a good thing if it would be applied globally. Yeah? It's not good if it's like something that is just an isolated solution in some region of the world. But if you had like global rules to play with, then that's like for everyone the same. That's good. But this difference in like, I don't know, US, Europe treatment makes it problematic. But what I really think is that privacy, some data is so problematic. Yeah. So if I talk about these GPS traces, yeah, if I knew the GPS trajectories of the people here in the room, you would probably. If you add small tweaks, small bits like whatever, searches, for example, yeah, search queries or location of like certain tastes of people, you would be able to isolate these people, to identify them for real. Yeah? So I see huge issues there. I see huge issues in this personalized medicine. I don't see it that much with like slum areas, but I mean, I know like in Germany, people didn't want to have Google Maps. Street View didn't want to have Street View at their houses. Yeah, so that's. I mean, okay, there might be reasons for that. Yeah, I mean, one being like the more the right-wing party didn't want to have their house visible in Google Maps, which makes sense because it's a house burned every now and then. But there are real issues. So.
I just wanted to add that monetizing data is difficult for companies. It's very difficult to make money by selling data, except for individual behavior data. And the same problem is in science, the problem of incentive. It's very difficult to get rewarded for data publications. However, what we see is that there are huge differences between disciplines. They are basic because the main factor driving data sharing is first societal impact. So scientists, when like we had the example today for the Millennium Development Goal, Sustainable Development Goal, when there is a possibility to have visible impact, scientists do share data. Second, peer recognition. So the community, in the community it is expected, and this is where, for instance, physicists are probably leading the pack. And the third point is mandates, but not mandates by policymakers, not mandates by funders, but mandates by publishers, because publication is the currency. So mandates by publisher are more effective than mandates by those who give the money.
Yeah, so one thing, like sharing from the experience with software. So back in days, we also thought exactly like we should require that source code to reproduce actually the machine learning results is basically published together with the paper. Yeah, and looking at last year's NeurIPS, to the biggest machine learning or AI conference in the world. There were actually, I don't recall the exact numbers. It was like 70 or 80% of the papers had software, yeah, published. And they did a survey. So that's like they did a survey like how many people did publish data, how many did publish the software and all the tools with it. And this number is increasing. So it's not like there is no data being published, but it's already. I think we are already on the way because the incentive is there. So it's not as bad as it might sound at this moment.
Incentives have been created. They were not there naturally.
Yeah, they're not their natural, and they actually also in the submission they now ask you politely to put paper there to add source code to your paper, and they will tell basically that's increasing your chances of being accepted. Yeah, so yeah. This sentence seems to be enough.
Okay.
Maybe I can build on that and my question. My question would be in terms of sharing data, making data available, particular with the focus of subsurface data. What is the role of the government? What is the role of the regulator and policymakers in providing the framework? And let me explain. We're here in Germany. If you want to explore for geothermal resources, if you want to think about energy storage, if you want to think about raw materials, you will have no real good access to the data that you need. Some of that is simply not available, but quite a lot of that is available, but not accessible. When I then look at other countries, and I want to pick out Netherlands, because they're here, and because of Norway, because they might be here, where data access is a much different game. There is data liberation, there is data available made to the public by default. The holding back of data is an exception. And in subsurface, we don't have data privacy or other issues. The point is, like infrastructure, if there's not roads, nobody will build them, but everybody wants them. So if the government plays that role, and that includes the research and academia, because if you're fully funded by public monies, why would you not have the obligation to provide the data to the public back? So my question is, what's the role of the regulators in providing the infrastructure such that there is big data in subsurface for machine learning?
Well, I could sort of give you sort of a history in the remote sensing world. If you look at the pre-2000 year 2000, before that, there were very limited data sources that were available publicly. AVHR, extremely crude, 8 square kilometer on each side. Like each pixel would be 64 square kilometer. It would be very, very rough information available. MODIS on Terra and Aqua, that was the first publicly available data source. Again, very coarse, half a square kilometer, half a kilometer on each side. And then USGS decision to make Landsat public just about a decade ago was a major game changer on top of that. MODIS was a game changer. And Landsat becoming public was another game changer. And I would sort of say today, Sentinel, following that lead, is a third game changer. So here already you see successive decisions by the government made which have tremendously advanced the progress in remote sensing context. And I think something like this has to be done in the context of subsurface geology. Some government has to be brave enough to make it available, and hopefully things would follow.
You just add, in Europe, at the European level, if you want to make the case for this, you need to use these two words, market fragmentation. So the fact that this is available in Netherlands and not in Germany, it's a barrier to the single market, and this is a case for European action. So this is a way to sell it. And the second point is the business case. Why does this matter? This is never enough explained to policymakers, and we need to get better at this.
Yeah.
I just add very quickly. I think another part of the business case is to view data and information as infrastructure. We're happy to capitalize an infrastructure project over 50 years. We need to look at the same process for data.
Yeah, I can comment to this question. Exactly in this moment, the government and the federal parliament is working on issuing a brand new legislation on that issue, trying to copy the Dutch model.
And there's a question at the back there.
Just in the meantime, so there's actually there's also benefit for companies in there, right? I don't know how many of you are old enough to know that like Netflix back in the days was like one of the first companies to open up their data set of like tastes of what users like, which movies they watched, and it created like, I don't know, like a fire. It was like the data set was being used by machine learners to learn and improve the model, and in the end they set up a price of like 1 million, I think, and in the end they ended up with a much better prediction model of who what movie to recommend to users. So there's also an incentive doing it also for companies.
Hi, I'm Albert Caruana from Malta. I'd like, first of all, thank you for all the interesting presentations. I'd like to just make a comment on what Matthias said just now regarding the data, subsurface data. There's other reasons not to make it publicly available. One of them is commercial reasons. Subsurface data costs money to acquire, and that data is normally licensed to oil companies when they pay a fee. So they have a right to view it in a data room, but they don't have a right to get a copy before they get a license. A second consideration is that in certain areas of the Mediterranean, there are still boundary disputes. So you've got data that's been acquired by a state, and if that data is made available to another state, that can prejudice the position from a sovereignty point of view. So I think one has to keep this in mind, that it's not just keeping data for the sake of keeping data not public, but there may be other reasons as well. Thanks.
Does anyone want to comment on that? What I would like to address, talking about different countries having different rules and sharing and privacy, I saw this talk of a woman who said they implemented in Estonia a digital ID. So that basically all your data is on this ID and can be accessed from the relevant groups. So for example, your medical data they don't have to keep repeating the different collecting the different data. So if you, for example, you have an accident, then in the hospital they can exactly see what your medical history is, which is sharing, which is helping to save doing a lot of work, double or quadruple or whatever, but the acceptance there is very high. So apparently 98%, I think she said, of the people have this digital ID. But I had a couple of chats before, and here I hear a lot of people saying, oh my God, that would be like my absolute nightmare. What happens if the data gets hacked? What happens if it goes around? How can one establish the trust?
I think we just have to accept that societally we have different expectations, different understandings based on history, clearly, and based on culture. You know, the Scandinavian countries in particular are far more open than probably many of us would be happy with. You know, the fact that how much money you earn is published and is easily findable in some of the Scandinavian countries. You know, I find that difficult, unusual, but it's different, and it will be different. I think from the company I work for, we've, you know, perhaps naively we thought that everything will be relatively the same and it will all soon work its way out and every country will end up being, you know, pretty similar. But that has not been the case, and I think you have to end up recognizing the fact that data sovereignty is still a big issue and it will remain so, and it's not going to disappear. So you need to build solutions that respect cultural norms, societal norms in different countries. And that may mean that sometimes sharing data is more difficult, and you know, it puts in place barriers to more efficient delivery of public services. But that's part of the process. I come from, you know, the UK, who is the National Health Service in the UK is the world's largest purchaser of fax machines, because our medical records are still faxed around between different institutions.
Yeah. But do you think it makes more sense to respect the different, the cultural differences, or wouldn't it make more sense to try and maybe bring a different culture to, or a different mindset to the countries in order for certain countries to not have a disadvantage?
I think you can suggest, you can demonstrate, you can identify best practice in other parts of the world and make suggestions, but there's no way that you can force these changes on society.
Just to add on this, since it's a topic that we know pretty well, there are a number of things that you can do, and it's clear that there are, I mean, Germany and Estonia are probably the two extreme of the different attitude to privacy. But first, show the benefits. I mean, if it's life-saving, people share data. If it's health, if it's operation, if there is a case, a clear case, the problem is that often there is not a clear case and people don't see the case. Second, guarantees. What they have in Estonia, they also have a symmetry where not only you share your data, but you know when your data is accessed by some agency, some part of government. So there is a symmetry, there is reporting, there is control, there is trust because of the technical capacity, because Estonians are very good at it and they've gained their trust. And government, I'm not speaking about Germany, but in general, government has a problem of trust when managing technology. And the problem is not only what if my data get hacked, which was the case also in the UK. I remember some laptops being lost and so on, but it's also the very perception of government knowing about me. So it's not only if data get hacked, it's also I don't want the government to know so many things about me. So there are cultures that you have to respect the different cultures, but there are things that you can do to change.
I mean, just imagine, right? I mean, okay, you have your ID, and I don't know what records are associated with this, but if you match them to something else, I don't know. Say you want to make these public for doctors only, and not other stuff, then it's of course giving you some kind of feeling of control over the data. But it could be matched with, could be shared with insurance companies, and then your the amount you have to pay for your insurance goes up. It might go like even I mean you know these models, right, where you based on your driving style are getting a different insurance. So there's so many things where you sacrifice a bit of privacy and get like a benefit, and also there's also kind of a loss part in this. So this definitely plays a role.
But on the other hand, that would be then something that could work through regulations. That you say, okay, the hospitals get access, but the insurance companies don't. That would maybe be a way to navigate.
Just say that there have been countless examples of regulation or provision to share data that have backfired because basically citizens did not accept this. And the issue goes much further than data sharing. The big difference between Estonia and Germany is not data sharing, it's identifiers. Germany does not want unique identifiers, and this is exactly the thing that Estonia has. So just a number that identifies that you can basically reconduct all the different data to this unique identifier. This is the main difference, not even about data sharing. It's just using a single identifier for persons. So there is a lot of work to do.
Yes.
I want to add on top of that. I think, of course, making this decision is not only culture dependent. I think it's also a very individual thing, and a lot of us does not have this trust because sometimes you are making this decision not full consciously, because you don't know what kind of consequence actually it has. I think all of us have come up with your browser, some kind of website, you agree on data policy. Who of you have actually understood what you are actually saying yes to? So I think this kind of communication will establish the understanding of what kind of consequence it could be. Transparency is a bit missing. If we could somehow making progress in this field, I think it will also definitely helps in helping more trust.
Very true.
I want to make a comment and probably continue with a question. I think when we're talking about Estonia and talking about ID, it's a lot about blockchain technology to keep this. Do you think it's also a solution to push data sharing, to include or think about involving blockchain technology when sharing data or, for example, programs or something like this? Especially in geoscience, because it's not that easy to share subsurface data widely, because it's also an asset. It's about talking about business models. It's a lot of big companies are sitting on a pool of big data, and they are not willing to share because it's a part of their business model. It's a big asset. So, and probably thinking about, and because you came up with the Estonian idea, blockchain technology can help. What do you think about it?
Most of the time, I seldom think blockchain is a solution to any particular problem. I think in those use cases where transactions and transaction history is important against the data set, yes, there may be a place for blockchain, but I don't see too many examples in the geoscience field. I could be wrong, but I don't see many.
If I can add, I just think, regardless of the technology, first, data sharing happened in Estonia before using blockchain, but now they do use blockchain. In general, tools such as blockchain that foster accountability and traceability are certainly helpful when it comes to modular discriminatory data sharing. But it's not the only answer to this question.
Mm-hmm. Yes.
I'd like to circle back and add a comment to Saron's response that company get a lot of benefits by offering data. It also happens on the country level. United States offer a lot of data for free, USGS, a lot of that data, and they, in return, they get a lot of benefits, a lot of good models are developed, and just they got it for free. And a lot of students from China, from different parts of the world, they just go and start with that data in the US. In the end, the US get that all this for free. On the other hand, I feel like I wonder what the panelists' opinion on the educational programs. I feel like a lot of geoscientists are taken by surprise by this wave of machine learning, but one of the main reasons is they don't have that educational background. Almost none of the hydrologists grow up being trained to do machine learning, and it's kind of a big surprise. So they start to fight it, in the beginning. So I want how can we create a better educational program for such things?
From a broader geospatial perspective, I've sat on the advisory panels and been an external examiner on a number of geoscience and GIS courses. And the point you make is a very valid one. There's not a huge amount of programming at all, let alone machine learning taught in many cases. Often you're taught how to use a particular software package, and it's almost like a driving license for that software package. And I think we need to get away from that. In an astronomy, if you want to make new discoveries, you end up building new telescopes. I think in geosciences, if you want to make new discoveries, you need to be in the position to be able to build new tools. And I think very few of us end up with those sorts of skills when we come out of university.
Actually, also in astronomy, you use machine learning nowadays, right, to discover things. But I forgot what to say. So someone else, please.
I have one more question. How do you feel the trust is in the technology, especially in geosciences? Because, for example, you were talking about autonomous driving. I know that there are a lot of people who are scared of the idea of giving the power to the machine because they don't 100% trust in technology. What is your experience? What? Who said, I heard, I don't trust?
I mean, trust is a process, right? It has to be established. It's like something that it's not like you don't immediately have trust, right? You need to slowly get used to the idea and then see that it is working. You need like whatever guarantees or you've seen it to like planes to fly and not crash very often. Then you start trusting that airplanes are safe. Yeah? And the same will be for autonomous driving. There will be like early adopters that are more like risk friendly. I don't know what the right term for this is. And then there will be people slowly adopting. Yeah. Now I remember what I wanted to say for the other thing. So it's actually a cultural. It's kind of a cultural thing, right? Machine learning. Like if you're coming from a culture and like you're in a community where basically the tasks were very like there was a lot of manual labor in there. Yeah. If you want to transform such community to use machine learning. And then this takes a while. Yeah, it's kind of the same thing with trust. You have to like see that the model is that these models are really doing a better job than your manual work would do, and it just takes time. So that's not something that you immediately get. Yeah? In particular, not when you have this hype in the press, right? About another breakthrough. There are no additional breakthroughs. There's always incremental process, but breakthroughs happen only once a decade or every 30 years. So the expectations are way too high, if you ask me.
I think you're right. The experience thing is important. I have a car that can park itself, or do parallel parking, and it took me maybe 5 or 6 goes before I was confident that it would work every time and not crash into other cars, and now it parks itself all the time, because, to be honest, it's better at parking than I am. But that's a process that's very visible. I think the issue around trust is in those times where the process is less visible by its very nature. And we need to be very careful of those times where, you know, an algorithm makes a decision or a machine learning tool makes a decision, and I have no transparency of how or why that decision was made. And that's something we need to work, you know, very hard on, making sure there's transparency in those sorts of situations.
Mm-hmm. Yes, please.
Yeah, adding on to transparency, maybe also, again, I want to highlight the importance of uncertainty. So far we are producing a lot of global things, but without actually being able to quantify uncertainty in the data and in the model, this means missing this error bar of these measurements still handicaps a lot of applications, I would say.
Okay. Any more questions? Yes?
Thank you. I'm from the French Geological Survey. Just a short question about the sustainability of, in terms of energy consumption for all these techniques. I mean, you use a bunch of data, a lot of big computers and so on. If you want to use AE for everything in geoscience, do you think it's sustainable as in the 10s or 20s coming days, years?
Yes, no?
I guess I'm assuming your concern is, are we embarking on a path which is going to use so much computing power that we're going to make it unfriendly to the environment? Is that the question? That is, the use of these algorithms may consume so much power, so much computing power, that becomes an issue by itself. Personally, I don't see that to be an issue. There are certain technologies like blockchain and so forth where that has been a concern. But here, in my personal experience, I think the gains you will get would be far, far more than the relatively small amount of computing power we'll be spending.
On top of that, I think in the beginning of, let's say, this honeymoon of AI, everything started with big data and big computer. Only the giant companies can do so. But I think the focus of the whole community is also changing. Now people are talking about efficiency, which means not anymore the bigger the model, the more data is the best. Instead, really try to get the best trade-off out of that. And if you talk about a huge amount of annotated data, they are also switching the focus to zero-shot, few-shot learning. Although they always there's a saying, if you have a choice to have a few-shot, never do zero-shot. But and at least I just want to highlight everything goes also towards the direction to be more practical and more applicable.
Yeah, I think we didn't hit like a wall yet, right? But we realized that we are approaching a wall, and then it's like what people are doing. They like start attacking the problem, right? But only when they become aware of it. So there's been lots of focus of like making these things more efficient. Yeah, like I don't know if you see how currently these neural network toolboxes are designed, they're like crazily optimized. They don't no longer use, for example, like whatever floating point 64, but integers of like 8 bits, so they save like lots of energy. These training algorithms, they are super aware of all the caches that exist, like from hard disk to your like level 1 cache on your CPU. Like all the steps in between are highly optimized. And then like if you look at like this Google's like EfficientNet, where you no longer train like super deep networks, but they are slowly like evolving over time, the depth and the number of neurons, then you see it also there. So the problem is being worked on. So.
Can I just say?
Yes.
I don't know, but what we saw today in terms of, for instance, addressing climate change is potentially mind-blowing. And if we will continue in 5 years to have a conversation about the energy consumption of machine learning, it means we really did not achieve the stated goal. Because, I mean, when you look at what you presented today, it's like, wow, you know, this should be, in 5 years, should not be an issue. If it's an issue, it means it didn't work.
I think you have to make rational decisions around these things. You know, if you think about it, you know, launching Earth observation satellites has quite a big impact in terms of, you know, releasing a lot of carbon. You know, Newtonian physics is tough. You know, putting stuff into space, it creates a lot of gases. So, you know, you have to make those balances. You know, what's the value of actually having something in space, measuring, you know, CO2, measuring NO2, as opposed to creating a lot of CO2, putting it into space. You have to make those value judgments.
Mm-hmm. Was there another question there, or? No. Okay. Well, so my take would be, as a summary, the words that stayed in my mind was ethics, that's very important, education, collaboration, sharing, and transparency. I would say for me, those are the most important takeaways. Thank you so much for this amazing exchange. Thank you, Vipin Kumar, Xiaoshang Zhu, Ed Parsons, Sören Sonnenburg, and David Osimo. Thank you very much. That was amazing.